Good morning. Welcome back. Today is Monday, and we're going to get started with a Nearpod lesson. I'm going to try to make some videos for you guys to help you walk through the Nearpod lessons, because a lot of times when you don't have live classes on Mondays and Wednesdays, you're going to have a Nearpod lesson, and this is for you to be able to interact, for me to see if you guys are understanding the material. And then remember, your Nearpod lessons are graded. So I will go through them and see how you're doing on them. So this is not something that we rush through to hurry up and get done. We need to be understanding, retaining the information, and participating fully in the information. So I thought it would be helpful for me to do a recording. So when I do this recording, I'm expecting you guys to pull up your Nearpod lesson with me, just as if we were in class together, so I can walk you through it. Again, if you have questions, you can always come to target time, and I'm happy to sit down and help you walk through it. But the best way to do your Nearpod lessons is for you guys to pull it up and try to have listening to me, watch me, and then you do. So if you need to pause while you do a part, and then keep going with the recording, that's perfectly fine. But again, my goal is for you to walk through this lesson and retain information. My goal is not for you to rush through and check it off your weekly checklist, but all of the information that we're going through in Nearpod lessons will be on your state test. So it is important that we're listening, reading, understanding, and doing a good job. So you can see my screen is shared. What lesson are we doing today? We're doing the law of superposition Nearpod lesson. That means you should have already done your lesson on Thursday, because I taught on the rock strata, the layers of the rock that help scientists come to a conclusion of a geological timeline, and how we look at rock strata and we look at the layers of the rock to look at how old the Earth is. And again, this is a theory. There are different scientists that I respect that believe different things, and this is why we analyze data, we have critical thinking skills, and we talk through this with the adults in our life. So with that being said, how do we do today's lesson? You're going to go on Monday. All right, right here you can see under your module, you should see law of superposition Nearpod lesson. You're going to click on that. When you click on that, I will be putting in your, you will have a link right in here, and you will click on the link and you will put your name in the link. All right, so I will be adding that link for you. And then this lesson should pop up, and this is what you should be doing. Now, remember, this is graded, so take your time. We are not rushing through this, okay? So let's go ahead and talk about the law of superposition. What in the world does this mean? So we're going to walk through this lesson. I'm going to do it with you today so that you understand exactly what to do, and there is no confusion, okay? So how do scientists use the physical world, meaning what the Earth is made up of, to deduce the age and the history of planet Earth? And like we've talked about before, there are scientists that come to different conclusions, and that's why we need to research and read and use our critical thinking skills to come up with our own belief and conclusion. So again, I'm just teaching you what the state standard says, and that's okay if you have a different conclusion, and that's all right. So in this lesson, you're going to learn how the Grand Canyon tells apart parts of Earth's history. You're going to understand how to determine the relative age of rocks and fossils. You're going to demonstrate your understanding of the law of superposition. All right, so that's what we're going to hit on today with this lesson. You're going to demonstrate your knowledge. And so I want to make sure you guys are understanding this as well. So let's get started. All right, so in today's lesson, we're going to learn how the Grand Canyon, all right, which I want to go there. If you have gone there, I would love to see pictures. But we're going to examine how to determine the relative age of rocks and fossils, and learn about and apply the law of superposition. All right, so hold on 1 second. There we go. What do you know about the Grand Canyon? So I want you guys to take a minute. You can pause me. Okay, I'm going to give you also about 2 minutes here as well, and I'll pop back on. You need to answer this the best that you can. What do you know about the Grand Canyon? I'm going to come back in 2 minutes, and I will be reading through your answers when I grade your Nearpod. So you have 2 minutes. If you need longer, feel free to stop me and play me again in a minute. All right, if you need more time, I encourage you to pause this video, but you should have written, what do you know about the Grand Canyon? Okay, so I want you guys to take a look at this picture. Beautiful picture of the Grand Canyon. I want you guys to look at the different layers. Do you guys see how there looks like there's lines? What would cause those lines? What do scientists do with those lines? There are different theories about this. And I want you guys to take a minute to look at it. Again, I'm going to turn my video off for a few minutes, and then we'll get back at it. If you need more time, you can pause this video. All right, guys, again, if you need more time to answer that question, you can go ahead and pause me. But we're going to go ahead and move on. I hope you described 3 things you noticed about that. 3 things that you noticed about that picture. Hold on 1 second. All right, so let's go ahead and move on. So the layers and layers of rocks, what is that? So the Grand Canyon is one of the most unique places on Earth. The Colorado River has carved out the canyon in layers of rocks that have formed, again, this is a theory, over hundreds of millions of years. Some people might believe different, and that's okay. We will learn more about how it was formed on the video on the following slide. Think about why learning about the Grand Canyon may be important. Again, remember, this is a theory based on our state standards. It's okay if you believe something different, but we are going based on the state standards, so keep that in mind when we watch this video.
Pretty awesome, isn't it? The Grand Canyon is one of the most spectacular natural wonders on Earth. 277 miles long, 18 miles wide at its widest, and more than a mile deep into Earth's crust. And unlike the Great Wall of China, you can actually see it from space. All of the water in all of the world's rivers would only fill it halfway. It almost defies belief. The Colorado River, the river that made this canyon, is only about 100 meters wide. That's not very big as rivers go. The Mississippi, the Amazon are far, far bigger, and they've never made anything like this. So, how did it happen? No one was around to see it form, but its story is written in all of those beautiful rock layers. Geologists are kind of like time-traveling detectives. They look for fingerprints here and there, retrace the footsteps to retell Earth's story as best as we can. Now, the Native American people in this area call this canyon Kaibab, which means mountain lying down or upside down mountain. And they didn't know how right they were, because down there at the bottom of the canyon, the oldest rocks are mountains.
The oldest rocks at the bottom of the canyon are named after the Hindu god Vishnu. About 1.8 billion years ago, the area that's now the Grand Canyon was covered in mountains taller than the Himalayas. But over hundreds of millions of years, erosion wore them down into hills just tens of meters tall.
From this point on, the evolution of the Grand Canyon doesn't happen in a dry desert like you see today. It happens underwater. Ancient oceans filled this area from 1 billion years ago to as recently as 80 million years ago. That water would rise and fall and rise and fall again, depositing sand and mud and even ancient seashells, compressing them into rock, piling layer upon layer and creating this colorful layer cake just waiting to be cut. But you might notice we're not at sea level right now. About 70 or 80 million years ago, this whole area took a tectonic elevator ride straight up, creating this high plateau. But there was still no river and no canyon. But northeast of here, that same uplift created the Rocky Mountains and their snow-covered peaks.
Melting snow began to flow and pool up in this area. Small rivers joined together to make larger ones, some pooled up into lakes, some even changed direction. And about 5 or 6 million years ago, the Colorado River was born.
That's not that old in geological time, but this river is special. It drops 10 feet for every mile that it travels and carries 500,000 tons of silt and sand and rocks downstream every day. It's like liquid sandpaper. It cut the plateau backwards, the same way that a waterfall wears away at a cliff, cutting this mile-deep scar like a hot knife through butter.
Excuse me, we're wondering, where's the Grand Canyon? Do you know where? We're trying to find, the Grand Canyon.
Here's an idea.
Oh! It's easy to know.
So that's how it got deep. But how did the canyon get so wide? Well, gravity took over, rain and ice chipping away at the canyon walls, and as it fell, it was carried downstream. Fossils and rocks from this area have even been found downstream almost as far as the Gulf of California.
And that's pretty much how we got the canyon of today. If you want to turn a mountain upside down, all you need is time. This canyon's still changing. It's getting deeper and wider, and as we continue to study it, the story of this canyon will change too. There's stories like this locked in Earth's crust all over the planet, hidden from view. But that little river has opened this one to us.
All right, guys. So hopefully that provided some explanation about the different layers of the rock and how they tell a story and how people interpret that story. So what do you think we can learn about Earth's history by looking at the Grand Canyon based on what that video said? Now, I want you, if you need to, you can always go back and rewatch the video. I want you, when you write this, do it in a full sentence, a clear explanation. I'm gonna pause this video and give you about 2 minutes to answer. Again, if you need more time, that is fine. But I'm gonna pause this and give you about 2 minutes. All right, if you need more time, then pause me and you can finish up. We're gonna go to the next portion of let's try it together. So let's talk about what is a geologist and what do they do? So this is a scientist who studies the Earth's rock to determine the history of the planet. So they're going to look at the rocks, they're going to look at the formation, they're going to think about it and determine what and conclude what they think is the Earth's timeline or history. So we talked a little bit about this in our recording on Thursday, strata. All right, so the scientific name of a layer of a rock. So when I talk about strata, I'm talking about the scientific name of the layer of the rock. We saw the layers of the rock in the Grand Canyon, okay? We talked a little bit about this also on Thursday, absolute age. What does that mean? So this is the exact age of anything. So for example, I'm 17 years old. I'm not really 17 years old. I am 38 years old. I had to think about that for a second. So whatever your age is absolute. It is a number. Relative age, that is the age of something compared to something else. So for example, I am younger than my sister, but I'm older than my brother. So you're comparing it. I did not say a number, right? I just used a comparison with another person. All right, so absolute age is a specific number, right? And then relative age is just a comparison. So let's talk about reading the rocks. How do you read the rocks? What do they do? So the Earth is made up of rock layers piled on top of one another. So sometimes the layers can be exposed by wind and water erosion. These rock layers are called strata. So do you see all of those little teeny tiny layers? Those are called strata. The geologists study the strata to understand the Earth's past. So this is the law of superposition. So what are the positions of the rocks tell us? So when geologists study the rock strata, they know that the strata gets older the deeper it goes. So this is called the law of superposition. So this cannot tell us an exact age. It cannot tell us whatever exact age this is. However, it can tell you the relative age or the age compared to something. So we can say that the layer on the bottom is older than the layer on the top, but we can't say if it's 5 or 10 or 15 years older. Does that make sense? I can't apply a number to it. I can only apply it. So this is, you can only tell this by a relative. You're comparing each layer to the other layer, but there is no specific number, okay? So think about rock layers like being a sandwich. You can better understand the law of superposition by thinking about making a sandwich. When you put down that first piece of bread down, that layer, this is the oldest. Why? Because we put it down first, right? And as we pile it up, each ingredient gets younger and younger. Does that make sense? So think about it like a sandwich. In the video, we said we even did a 7-layer bean dip. The layer on the bottom was first, so it was the oldest, okay? So what do we talk about strata disturbances? So sometimes the strata, which we're talking about each layer, right, of the rocks, it's disturbed. And we're gonna get into the plate tectonics in a little while, but sometimes underneath, below the Earth's surface, it shifts, okay? And this can cause the rock layers to tilt, to break, to bend, and to move. So take a look at this. This is a little bit crazy. So underneath the Earth's surface, those plates moved and shifted. And look, that's kind of curved. Do you guys see that? Look at this. There's a crack right here, and all of this shifted. The plates moved, which caused it to shift. So let's look at this intrusive rock. So sometimes We have rock layers that will be disturbed by molten rock that push, it's going to come up from underneath, and this causes an intrusion or breaks it right in the middle. So we know that an intrusion is younger than the rock it sits in because the strata needed to be there first in order for this to push through. If there was no strata, there would be no pushing through. So this has to be pushed through the strata. So it's similar to thinking about a toothpick. And when you put the toothpick through the layers of our sandwich, okay, this is the same way with an intrusion or intrusive rock, where that rock is coming through those layers. And even though it's in the middle, it's still the youngest because it's new, okay? So why are rock layers like a sandwich? I'm going to give you 2 minutes to give me your best explanation. Again, if you're going to need longer than 2 minutes, you can always pause this video and then start again. So I'm going to give you guys about 2 minutes to go ahead and write your answer. Why are rock layers like a sandwich? All right, I cannot wait to read your answers. Again, if you need more time, go ahead and pause me. But I cannot wait to read why are rock layers like a sandwich. Okay, so what does this mean? We're gonna watch a short video, but it's important for geologists to understand the law of superposition. By digging deeper into the earth, they are digging deeper into the Earth's history. This allows geologists to understand how the Earth was thousands and some people might believe millions of years. So let's travel back to the Grand Canyon to learn more in the following video.
Every step you take up the Grand Canyon is like a leap of tens of thousands of years in time. Where one band of colour ends and another begins signifies a dramatic change in conditions on the Earth. Geologists have managed to read between the lines when it comes to rocks. They can select a rock and get to know it, discovering how old it is and how it was formed.
One of the best clues to learn about a rock's past are fossils. And in this petrified sand dune, I've found reptile tracks. These are all individual footprints of probably the same lizard or early reptile that walked up the face of this sand dune. And this particular footprint here nicely shows the individual toes of the animal.
Geologists have studied these rocks and discovered that about 260 million years ago, this layer was desert. But as we reach the top layer, which is about 250 million years old, we discover fossils which belong to a completely different environment.
What we see here once used to be a broad, warm, shallow sea. And the reason that we know that is we've come across the rock type called limestone. And limestone is made up of a bunch of little bits and larger bits of shells. And I'll just wet this shell right here to make it stand out a little bit better. It's called a brachiopod, and it's much like the shells that we find on the beach today. You can see the outline of the shell here, just as the oyster has an outline to its shell, and the brachiopod has a hinge here where the two valves come together, just as an oyster has a hinge here. And this fossil shell here is from a creature that lived in a warm, shallow sea 275 million years ago. And here's another one down here. These fossil shells are part of this limestone rock layer that makes up the final layer at the top of the Grand Canyon. All these brown knobs sticking out of the limestone are individual fossil sponges. And we have a better example over here. What we're looking at here is a fossil sponge, and we know that because we can see these nicely preserved pore spaces, just like modern sponges have. And we know that modern sponges live in warm, shallow seas. Therefore, this sponge probably lived in a warm, shallow sea also. Well, we made it. You know, making my sandwich is very much like how the Grand Canyon was made. If you think about this white piece of bread and the mustard on top of it as one of the sedimentary layers, and then this piece of cheese could represent the next layer that was deposited on top of that. These pieces of salami would then represent the next youngest sedimentary layer. So the white bread would be the oldest layer, and the salami would be the youngest layer. And then sometimes, after layers are deposited, they're then removed again. And then later in time, more layers are deposited on top of those.
The Grand Canyon is not a complete record of time. Some layers are missing. The top layer was laid down about 250 million years ago. The layers which tell us about the age of dinosaurs and our own human history should be on top of the plateau. These layers have been eroded, washed away by wind and rain over a very long period of time. The layers may be missing at the Grand Canyon, but they still exist nearby at a place called Echo Cliffs. The rocks in these cliffs were once present above the Grand Canyon, but have been eroded. They are millions of years younger than the top layer of the Grand Canyon. We know this from the fossilized dinosaur tracks that have been found in these rocks. Recorded in the rocks of the Grand Canyon are about 2,000 million years of the Earth's history. It has helped to write an important chapter of the Earth's past.
All right, friends, so let's go ahead and move to the next portion of our lesson. How do geologists know that there was once a vast sea where the Grand Canyon is today? So based on that information, how do they know that there was water there? I'm going to give you 2 minutes. If you need more time, pause my video, go back and watch the video, but I'm going to pause. I'm going to wait for 2 minutes for you to answer that, and then I'll be back. All right, again, if you need more time, pause your Zoom recording. You can keep writing away and then play me when you're ready. So I cannot wait to read your responses. Let's try on your own. So think like a geologist. In the next few slides, you will be asked to differentiate between different layers of the Earth based on their composition. You will also be asked to identify which time period each layer is associated with. So you're gonna need to observe, read the graph, and look at the different layers. Okay, so you're gonna need to slow down, look, observe, identify. All right, so let's do this one and see what you guys come up with. So circle the oldest rock layer in the diagram. Well, if we're talking about the oldest layer being on the bottom, so circle the oldest rock layer in the diagram. That's gonna be at the bottom, just like a sandwich. So remember, we would circle this area, or you can circle the whole one. But we're trying to identify the one on the bottom, right? Because that's gonna be the oldest rock layer. So that's what you should be looking for in your Nearpod. All right, so go ahead, circle the oldest rock layer in the diagram. Now the next slide is gonna get another specific. Circle the youngest rock layer. Now, they may try to trick you because if we first look at this, our eyes might be drawn to this layer. But is that the youngest? No, because we have this layer and we have this layer. So the youngest layer is going to be the top layer. So out of all of these layers, this would be the youngest because it's the one stacked on the top. Okay, so you would circle just this one. Now, which organisms, so now we're going to be looking at these little organisms, which organisms lived further back in time? All right, so is it ammonite? So we're going to have to find it. So here's the ammonite, right there, right there. You don't have to circle these. I'm just showing you how to find them. Or the trilobite, which is here. Now, if we look at this, which one is older or on the bottom? It's going to be the trilobite, right? So you're going to circle it in the oldest layer. So you're not going to circle these, right? Because that's not the oldest one. So you will not circle these, or you can erase it. But you are going to circle the one on the bottom. Okay? Hopefully that will help. And we know that this is the oldest one because if we're going by the strata or the layers, the oldest one is going to be on the bottom. All right? All right. Explain how you knew which organism lived further back in time. So how did you know that this one, trilobite, not sure exactly how it's pronounced, but how did you know this one, like we just talked about, was the organism that lived back in time? Go ahead and explain your answer. I'm going to give you 2 minutes. If you need more time, stop me and then press play when you are done. All right, friends, can't wait to read your answers. I know you guys did a great job. Let's go ahead and move on to the next slide. Let's see what you've learned. So I want you guys to take a minute to go ahead and fill in the blank. All right, fill in the blank. You should have it pulled up where you're filling in a sentence. I'm going to give you 2 minutes, then we're going to go over the answers together. All right, I'm going to give you just a minute or so. Go ahead and stop this video. You should use the word bank, fill in the blanks, and then we'll go over it together. All right, so let's go over that answer. This should have been super easy for you. The law of superposition states that the oldest strata is found at the bottom of a rock formation and the youngest layers are found at the top. Geologists can analyze rocks and strata to understand the Earth's history. So hopefully you guys got those correct based on our lesson today. And then I want you guys to take a moment to do this quiz. The law of superposition states that younger rocks are deeper in the Earth's crust. Older rocks are deeper in the Earth's crust. Or it is impossible to tell which rocks are older. This should be super easy. Choose the best answer. And then go to the next question. Oh, hold on. Sorry, guys. I'm going to let you guys on your own finish the quiz. So if you need to pause me, pause me. I don't want to show you guys the answers because I do want you guys to do the quiz on your own because I am going to grade that part. So let's go ahead and go to the next part of reflect. So let's reflect. All right, I want to hear your words. This is our open-ended question part. How does the law of superposition help determine the age of fossils compared to others? So think about those rock strata layers. Think about how those layers tell us a story or a timeline. Which layer tells us the older time frame? Which layer is on the younger? I'm going to give you 2 minutes to go ahead and finish this question. All right, if you need more time, you can pause me. And then the last question is after today's lesson, how do you feel about the law of superposition? Do you feel like you are confused? Do you need more practice? Or are you a pro and ready to move on? So just as a reminder, you are graded on this Nearpod lesson. Please make sure you do the fill in the blanks, you answer the questions appropriately, and you do the quiz. I will give you guys feedback. Again, let's look at what you have to do. Remember, always go to the modules. And today you should have done your Nearpod lesson. Tomorrow, I'm going to go over fossils. On Wednesday, you're going to have a Nearpod lesson. Thursday, I'm going to teach you a live lesson. And then Friday, as always, you're going to have your green dot challenge. This is the second week of trying to master your cycling of water. So if You guys have any questions, feel free to reach out. If not, I can't wait to see you guys tomorrow for our live lesson. And I hope you guys have a great day. Bye, guys.